Okay, so for this video, I just wanted to go with you, since I'm not there, step by step how to do a couple of the problems that I've assigned. So you're required to do pages 8 to 9, numbers 7 through 14, so I figured we could talk about a couple of these problems here if you felt like you needed some explanation. So we have to graph this rational function, or actually in this case we don't. We just have to find all this information about it, which you need to find when you graph anyway. But the first thing we always want to do is to factor anything that we can. In doing so, that's going to help us find our vertical asymptotes as well as any holes. So in this case, our points of discontinuity would be just a vertical asymptote because we don't have a hole. If we look and see and we factor, nothing will cancel out. So if something were to cancel out, that would create a hole. But in this case, none of our factors match, so we can't cancel anything out. To find the vertical asymptote, we take our denominator and set it equal to 0, which is what I've done here, and I solve for x. So my vertical asymptote would be at x equals 1. To find my x-intercepts, I plug, or I set my numerator, I should say, equal to 0. So I have my numerator of x equal to 0, so my x-intercept would be at 0, 0. My horizontal asymptote, I look at the degree of my numerator and denominator, and these degrees match, so my horizontal asymptote is going to be at the ratio of the leading coefficients. So the leading coefficient here is 1, and down here it's -2, so my horizontal asymptote is at -1/2. My domain, because I only have one point of discontinuity, the vertical asymptote, is just going to be all real numbers except wherever my asymptote was, which was at 1, and I just write that by writing x cannot be equal to 1. I'd like to now skip to a problem where there is a hole, and I don't know if any of the ones on this page have holes. No, it doesn't look like they do. So then, if we go to pages 12 and 13, there was an example here that had a hole. Okay, so like number 8. So again, factor, and this one's also a good one to go over because it has a slant asymptote and not a horizontal asymptote. But we factor the numerator and factor the denominator completely, and we can see that we have this matching set of factors that cancels out. That's what creates a hole. So the factor set equal to 0 will give us the x-coordinate of our hole, and I get the y-coordinate by plugging the 3 into my simplified fraction. So when I plug in 3 for x here and here, I get 3 times 6, which is 18. Is that right? Yeah, I just want to make sure I'm doing that in my head correctly. And then here we get 3 times, this would be 4 or 12, so we get 18 over 12, which reduces to 1.5. So you can see that on the graph at 3, 1.5, there's an open circle. That's how we graph a hole. And the last thing that I want to point out in this question specifically is the fact that we have a slant asymptote. If we take a look, the degree of our numerator is bigger than the degree of our denominator. So we have to find the horizontal asymptote doesn't exist, and we have to find our slant asymptote using division. So that's what I'm doing here. And I get y equals 1/3 x plus 2/3. So my y-intercept is at 2/3, and I rise 1 and run 1 to get my the slope of my line, excuse me. Another way to graph this, because using slope-intercept form is kind of a bummer in this case, would be to plug that into your calculator and find key points. And once you have one key point, you can use your slope from that point to graph them so that you're not graphing in between boxes. Okay, so anyway, you have your slant asymptote and your vertical asymptote graphed, and then once you do that, you plug this into your graphing calculator and find other key points. So you can see that that's what I've done, and aside from that, we're basically just hugging the asymptotes. And that's pretty much how we're going to graph rational functions. Like I said, they're all a little bit different. They're all going to look kind of weird. If you look at this one, we actually had 2 vertical asymptotes, so we end up with 3 sections of our graph. They can look all different. This is one where we have a horizontal asymptote, but we actually cross it. The reason why it's still considered an asymptote is because these parts of the rational approach that line infinitely without ever touching it. But there are going to be parts or occasions sometimes where a horizontal or a slant asymptote will be crossed. This is another example here in number 10. But vertical asymptotes, again, will never, ever, ever be touched or crossed. Just horizontal or slant. Anyway, looks like here I didn't finish my graph, so it should have gone further down here. But anyway, come see me, guys, if you have any questions. I will be in on Wednesday, and we have advisory on that day as well, and I would love to hear what you guys think of this. So I will talk to you soon.